first thing we're going to review from this quarter is how to identify congruent triangles and do proofs with congruent triangles. So with that unit, we talked about looking at corresponding parts of congruent triangles. So in these two figures, angle P is going to be congruent to angle L. Segment PQ is going to be congruent to segment right here. And if I'm saying P first, I need to use the corresponding vertex, which would be L. And that is going to end at J. So when I'm talking about congruent or even similar figures, the order of my vertices matters. Then we have QR, and that's going to go with JK. QR, JK. And then triangles, we want to do our little triangle. R matches with K, Q matches with J, and P matches with L. Sometimes they don't give you a picture and you just have to look at the letters. So given triangle MAT is congruent to triangle CUP, complete the congruent statement. So MA, I notice, is the first two letters, so those are going to be congruent to CU. TM, that's last to first, is going to be congruent to PC, last to first. And angle A, that's my middle letter, so it's going to be congruent to angle U. For congruent or not, we had some theorems that worked and some that didn't. So we had side, 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 angle, side, angle, side, angle, 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 side, and HL, which was hypotenuse leg. The two that don't work are AAA and the bad one. You know what I mean. Dun, dun, dun. All right, so looking at my first figure, we can add things using the reflexive property, which means that they have a shared side, or they have vertical angles. That means they kind of look like a bow tie. Or if they have parallel lines given to us, we can do it. Otherwise, I can't just start randomly adding markings. In this picture, I have a shared side, so I can add that. And if I look at the type of information I have angle, side, angle in both triangles, so those are congruent by ASA. Going to the next one, I have another shared side, so by the reflexive property, it's congruent to itself. And now I notice in both triangles, I have side, angle, side. Moving to the right, once again, I have a shared side, but I don't have any other information, so this one is not necessarily congruent. Not necessarily congruent. Could they be congruent? Sure, but they aren't necessarily congruent. This next one is our first instance of vertical angles. I have that bow tie going on, so I have vertical angles, and thus these are congruent by side, angle, side. More bow tie or vertical angles going on here, and I have ASA. I have a reflexive property here, shared side, and those are going to be angle, angle, side. Another shared side, so that's reflexive property is congruent to itself. I have a right triangle because of that right angle, and this is going to be HL. Usually it would be SSA, but HL is a special situation where they are congruent, and that has to do with the Pythagorean theorem. Put your congruent side, and now I have side, angle, side. This next one, I notice I have a right triangle. What pieces of my right triangle do I have? Well, opposite my right angle, that's called my hypotenuse, and then I have another side, which is my leg, so these are congruent by HL. Same thing is going on this bottom problem. We have the side opposite our right angle, which is called our hypotenuse, and we have another leg. But just because it's a right triangle doesn't necessarily mean it's HL, so don't get all excited every time you see a right triangle that you think it's HL. I could have still side, angle, side, I could have ASA. You have to have the hypotenuse and one of the other sides. Got a bow tie going on here, so this one is ASA. And last guy, we have a reflexive property, can add this side in, and we have side, angle, side. Now we're going to look more at the basics of proof. So these first ones, they're kind of like the pre-proof things, which some of you got so good at proofs that you were overthinking them. When it says, y is the midpoint of RD, I just want you to tell me, what is the one thing, if y is the midpoint, what is something I can conclude? I can conclude that RY is congruent to dy. Why can I conclude that? Definition of midpoint. All right. The next one, I can conclude a few things. If UY is perpendicular to RD. The first thing is, what does it mean for something to be perpendicular? It means that it's making right angles. So that means automatically that angle UYR and angle UYD are right angles. After that, since they're right angles, I can conclude that those two things are congruent because all right angles are congruent. I can also conclude that those two triangles are right triangles by definition of a right triangle. All right, UY, oh no, we're missing weird letters, bisects RUD. Something got messed up on our picture. Oh, no, this goes with this one. JK. Sorry about that, y'all. I'm together with my life. So UY is bisecting RUD. That's an angle. I know you know that's an angle, but that means that my answer should have to do with angles. If I'm bisecting an angle, this has to do with angles. If I'm bisecting a side, it has to do with sides. So since I'm bisecting an angle, RUD, that means that RUY is going to be congruent to DUY. All right, so if it's bisecting an angle, your answer has to do with angles. If it's bisecting a side, your answer has to do with sides. Okay, now let's go to the correct diagram. DA is parallel to QU. Okay, so when you're talking about parallel, I want you to imagine that these sides just keep going out. Now do you see we have this diagonal going through? That's like a transversal back in Unit 3. So we actually have two different things you could conclude. Remember we made a zigzag? Whee! Here's my zigzag, and the interior of my zigzags are congruent. So that one would be that angle DAQ is congruent to angle UQA. I could also have done a zigzag the other way and gotten the other two angles, but I'll just go with that one. Cool. What parts are congruent just by the picture? So that's saying if I just looked at that picture, what could I have said was congruent? And that's going to be that QA is congruent to itself. QA is congruent to, technically it's going to be AQ, but it's congruent to itself. So let's do one proof together. Given C is the midpoint of AB and angle A is congruent to angle B, prove that DC is congruent to EC. Alrighty. So what do we always start with in a proof? We start with our givens. So I have my statement and I have my reasons. So I have C is midpoint of AB given angle A is congruent to angle B which is given. So it gave me angle A is congruent to angle B, so I'm going to go ahead and mark that on my diagram. A congruent to B. So I've used this information. Have I used that C is the midpoint of AB yet? Nope. So now I'm going to use this. C is the midpoint of AB. So here's C. And if C is the midpoint, what does that mean? It means that AC is congruent to BC. So AC is congruent to BC, and the reason is definition of midpoint. Okay, now what else do I have going on in this diagram now that I look at it? Well, I know that these two angles are congruent because they are vertical angles. All right, so let's write what those two are. So we have angle ACD is congruent to angle BCE. And now I have enough information to say that these two triangles are congruent. So triangle ACD is congruent to triangle BCE. And the theorem is angle side angle. But that's not what I want to prove. I want to prove this. All right. So what was our favorite thing we used in this? CPCTC. Corresponding parts of congruent triangles are congruent. And since we've proven that those two triangles are congruent, we can conclude that these corresponding parts are also congruent.